So in this lecture, we have seen how the C programming language represents strings as null-terminated arrays of car. Remember, this word null is not the same as that special pointer that malloc returns. We write that with all caps null, N-U-L-L, but this null character is that escape 0 letter that we saw. Now we have seen that our string.h header file does contain lots of helper functions that make it a little bit easier to handle C strings. So for example, there is the strlen function, there's the strcmp function, there's also an strcpy function for copying strings. But it turns out it's much harder to write C code for processing strings. I strongly suggest that if you need to write a program to handle strings, use Python. Your life will be much simpler because Python strings are much more powerful. There are many more helpful methods and operations that are directly available to you in Python without having to write low-level C code. We have seen that in general, an array is a contiguous chunk of memory, and it starts at some location which we call its base address. Now, when you want to give an array as an argument to a function, all that is copied is that base address. We do not make a copy of all the items in that array. We could do so, but in general, when we call a function with an array argument, that does not happen. We simply get a copy of that base address. And if we want to return an array, whether it's an array of characters or something else, that we have to be very, very careful of. It should not be the address of a locally created array, an array that was created on the stack. If you want to return an array, then you must create that array on the heap, and then the person who received that is responsible for freeing up that memory. So the three ways of allocating arrays: a fixed length, which is allocated on the stack, a variable length, which is again allocated on the stack, and on the heap. And we have seen there is this malloc function, and in the stdlib header file, there are a few more functions for allocating memory. For this course, we'll just focus on malloc. It's very important as a C programmer to remember that you are responsible for handling this memory on the heap. A very common error is for us as programmers to allocate memory and then to forget to deallocate it. That will result in what is called a memory leak. In my old laptop, I used to have an extension to my browser. And over a few days, that extension would consume more and more and more memory, and at some point my laptop would get very, very slow, and perhaps it could even crash. That browser extension had a memory leak. Fortunately, in my current system, that same extension doesn't have that problem. So keep in mind that memory leaks can lead to all kinds of problems, and as C programmers, our lives are much more complex because we have to deal with it. In Python, you don't have to worry about these things. The Python system handles memory allocation and deallocation for you.